everybody. In this lesson 11.2, we're going to find triangle similarity shortcuts. If you remember from much earlier in the year, we had triangle congruence shortcuts, which allowed us to save some time by instead of checking all three pairs of angles and all three pairs of sides and making sure that they were congruent, we found, for example, if we just checked side angle side, two sides in the included angle, that was enough to say they were congruent, or side side side, or angle side angle. Okay, we had a couple variations there, but those were for the congruent shortcuts. We have similar things here, but to determine if the triangles are similar, of course, not congruent. From the Desmos activity, you should have found that angle is, and you might not have thought about it this way on Friday, but this is a similarity shortcut, meaning if you just make sure that two pairs of angles are congruent, that's actually enough to determine that the triangles are similar. Okay, so we have two pairs, let me say if two pairs of angles are congruent, then the triangles are similar. Okay, this, you actually see this concept all the time. I'm going to use a star. I know it's not a triangle, but I want to just talk about this concept here. Think about how many times you take your phone and pinch and zoom, right? So by doing that, notice we're not changing any of the angles. Like if I had patty paper and I could put one, oh, actually I can't. Look at this. Let's look at these vertices here. I'm lining up these two stars. See, all these angles are the same. So when you're talking about similarity, the angles don't change, but the sides, of course, can. That as opposed to this, let me show you an example here where they're not similar, right? Look at what's happening here. So now I am kind of changing, look, these angles at the top don't match. These angles are clearly not the same size. So these are not similar. Okay, and I know these are not triangles, but I think that's a good way to think about it. All right, so those two are similar. This third one is not. All right, so this was kind of our new big triangle or similarity shortcut, excuse me. Now that means also that anything that has two letter A's in it falls in that same category as well. And we'll list these all out in a minute, but having all three angles is also good enough. Having two angles and you might have a pair of sides mentioned in there, great. Whether it's the included side or not, that all is fine. So angle, angle, side. Well, again, we'll list all these in a minute. As long as there's two A's in there, two pairs of congruent angles, the triangles are similar. Side still works, but here's where this varies a little bit. Instead of having all three pairs of sides congruent, we need all three pairs of sides to be proportional. Okay, so if all three pairs of sides are proportional, then the triangles are similar. Apologize for this giant watermark over here. Unfortunately, my free trial of Smart Notebook ran out, so that's going to be here till the end of the year. I don't know how to get rid of that, and I can't cover it up. Sorry about that. Okay, so side works. Now, let me remind you, go back to what you did in 11.1. The sides are proportional if the ratios are equal. So you would be comparing corresponding sides, setting up three different ratios, fractions, and making sure that those three fractions were actually equal to each other. Okay, and then a third one, when we would have tested this out in class, but side angle side also works. So you might only have two pairs of proportional sides given to you, but then you also have to have an included angle in between that's congruent. Okay, so this would have two pairs of sides are proportional. And the angle in between is congruent between the two triangles. Okay, so angles are not proportional, angles are congruent. That's a little bit of a change we'll have to get used to. Okay, so let's list all of our possible similarity shortcuts. Okay, so here's our triangle, similarity, shortcuts. Here we go. So we started off with Angle, angle, and that's really the big one. That's the most common one we're going to see. So that again means anything that has two A's and it also works. So maybe they have all three pairs of angles marked congruent. Great. Not necessary, but also works. They might have some information about an included side. Not really useful, but fine. That works as well. That side might not be included. If you remember this, that's the same thing. It's just where you're seeing the side, which side is it on? Side, side, side is a shortcut. Side, angle, side is a shortcut. So now the only one that doesn't work, I'm going to write it this way. Remember how you read that one backwards? Because there still are two possible triangles created with that given pair of sides and non-included angle. So that doesn't guarantee congruence and it doesn't guarantee similarity either. Okay, let me try a couple practice problems here with you. I'll have you do a couple on your own. So if you want to reference these in the book, they are from page 591. I have them renumbered just so they're nice, neat, 1, 2, 3, 4 in our notes, though, but you can find the matching picture if you want to see them. Okay, so for all of these, the directions would have said this, but the first thing we need to do is determine if the triangles are even congruent. So I think an option is to write cannot be determined. Oh, excuse me, not congruent. Determine if the triangles are similar. Okay, so one option would be to say cannot be determined. Triangles aren't similar. I can't set up a proportion. I don't know. Now, number one, this again is the most common shortcut we're going to see, and frankly, I think the easiest one. This is what angle, angle looks like. Two pairs of congruent angles. Done. So we've got angle, angle here. I'm just going to put a check mark, just a note to myself that yes, I checked that they're similar. We're good. Now from here, we can set up our proportion. Okay, so what we're looking for, and you did this in 11.1, but let me do it specifically with a triangle now. We are looking for a pair of sides, whose lengths we already have, a pair of corresponding sides. We've got 24 and 30. That's sort of the ratio I'm going to use every time when I'm finding any other missing side length. Okay, I've got 24 to 30. If you'd like to reduce that, great. You can make that 4/5, or you can leave it as 24 over 30. It doesn't matter. Okay, I think for now, I'm going to make this 4/5, right? So that's equal to 4/5. Oops. And just to make it a little bit easier to work with these fractions. Okay, so this is the ratio I'm going to use to find h and then to find k. Just remember though, 24 is a smaller one, so my smaller triangle is always going to go in my numerator when I set this up. So 4 over 5, sorry about that. 4 over 5 is equal to h over 50. See why it's kind of nice to use 4 over 5? I can see my scale factor here, right? This is times 10 times 10. So h is just 40. Now, it's not that the triangle is 10 times bigger because I scaled this down. I scaled it back to start, right? I reduced that. Okay, and then to find k, so I'm going to use 4 over 5 again. This time I have the smaller number. That's equal to 32 over k. I like this again because now I can see, oh, from here to here, this is just times 8. So I'm going to do this, times 8. Okay, so it turns out k is actually 40 as well, but those are not corresponding sides, so don't be concerned that you got the same length there. Both of those happen to be 40 though. Okay, now number 2, it's hard to tell at first glance that these are similar. They don't necessarily look that way, but they do have angle, angle marked here, right? There's one pair of congruent sides. Here's a second. Okay, so they are similar by angle, angle. I'm just going to make them look a little more similar by redrawing them so they're kind of in the same position. So I'm going to keep this triangle here as is. And then I'm going to redraw triangle AKR. But the one tick mark angle, I'm going to sort of line it up in the same, oh gosh, I didn't think this was going to go super well. Just tracing here, sorry about that. I'm going to line it up so they're in the same position. So I want one tick mark in the bottom left, 2 tick marks in the bottom right, and then I'm going to transfer my labels over here properly. So R will go down here, K is by the 2 tick mark angle, and then A actually ends up on the top now. Transfer over your length too as well. So AR is 24, and AK is M. Now, so I can kind of ignore this one for now. Now I'm just trying to set up my proportion with what I have here. So 24 and 36, got it already. So 24 over 36 equals m over 42. Be consistent in how you're setting this up. Since I put the smaller triangle in the numerator here, smaller triangle has to go in the numerator here. So look at 24 and m. Okay, that ends up being, so I think 28 when I solve. If you need to, again, go ahead and, in fact, let me work through one of these since it's been a couple days. Let me cross multiply here. So I get 36m equals 24 times 42, 1008. I don't care so much about that number because I still need to divide by 36, and that's where the 28 comes from. Okay, now we'll also see some problems that say determine if they're similar or not. So we want to see what's going on here. So we potentially have side angle side here, which is a similarity shortcut, but you have to check, are the sides proportional? So the angles are good. We've got that part out of the way. So we're trying to figure out, do we have side angle side? So the way that we test this is set up this proportion. So let me do here, I don't know which way I want to do it. How about 37 over 30? So kind of the bottom sides there. Does that equal 37 over 30? Does that equal 35 over 28? And really the easiest thing you can do, I think, is just in the calculator, divide this, get a number. So I get, let's see, 37 divided by 30 is 1.23333, repeating. 35 over 28 is 1.25. Those are not equal. So our triangles are not similar, right? The sides are not proportional. Okay, so you can't just say, oh, look, they're side angle side, because you have to test out if they are proportional or not. Okay, I need this little watermark's going to get in the way. Here we go. Okay, so number 4, one more here with you. Y is triangle SUN, so this little guy here, similar to triangle TAN. And then once we figure out that, we'll try to find R and S as well. Okay, so SUN, TAN. Now here's one thing I know I can mark right away, right? Vertical angles. Great. If we can find another pair of angles, that's enough to test or to say that I've got one of my shortcuts. This was way back from the circle unit. I want to look at this arc right here. Angle A is inscribed and it's intercepting that arc. Angle U is inscribed and it's intercepting the same arc. If you remember, they would both be half of that arc's measure. So let's say that this arc is like 120 degrees. A would be 60 and U would be 60. I could do the same thing with T and S, or I could just use the third angle theorem to say they're the same, but I don't really need to. Once I have angle, angle, that is sufficient. So they're similar by angle, angle, and then we could do the same thing here to set up R and S. Feel free to do that on your own. Okay. All right, I'm going to ask you to do the problems from the yellow packet. I'll link that to the Google Classroom again if you didn't print out the whole thing. That's fine. Remember, you can do these on scratch paper. You don't have to print anything. I'm okay with you just numbering and having it nice and neat and organized. But let's do 11.2. And then when you're done, just submit a photo of your completed work. Please make sure it is your work and your work alone. Okay, as always, let me know if you have any questions. Have a great day.